So this is our system for which we have to find out the acceleration of masses m1 and m2. The mass m1 is placed on the wedge having angle of inclination as alpha, and which is attached to the string which is connected to this pulley, which is a movable pulley, and this pulley is a stationary pulley, it is not movable. And then there is another thread going upon this pulley and attached to this mass m2. We have to find out the acceleration of both the masses m1 and m2. So let's do that. So now what we will do first, we will assume that this mass m2 goes down. So if this mass m2 goes down, m1 will go upwards the plane, right? So let's write the tensions. Okay, so here the tension is T, suppose. Then here also and here also the tension will be the same because it is the same string going over the pulley. So here the tension is T, here also the tension is T. And let's say here the tension is T dash and here is the tension T dash. Okay. Now what will happen if this pulley is gone upward like this by a certain amount, let's say by certain amount x. If this pulley is gone upward by certain amount of x, then this string has to go down by amount 2x. Why? Because this end of this string over here is fixed here, and this another end has to go 2x amount so that it can take this pulley upwards by x amount. So this string has to go down by 2x amount, so it will go by 2x amount. So if I talk about acceleration, the mass m2 will go with the 2a acceleration downwards, and this pulley will go upwards with the acceleration a. And by the same logic, m1 will also go upwards by an acceleration a, upwards. Okay, so now let's draw the free body diagram to find out the accelerations. So now the acceleration for this m2 will be, so let's draw the free body diagram first. The upward force is tension T, downward force is m2g, and the acceleration is downwards 2a. So m2g minus T is equal to m2 times 2a. This is my first equation. Let's draw the free body diagram for the m1 mass. So for m1 mass, what we will have here, so the m1 mass is like this, right, which is placed upon the inclined plane. So in this direction there are the two tension forces, sorry, there is a T dash force, not two tension forces, T dash force is there, and here there will be another force. So what is that force? So if m1g is the downward force, then it's this component will be the force in this direction. Now if I say there are two components of m1g, then what will be this angle? This angle will be alpha. Why this angle is alpha? Because if I see this will form a right angle triangle. If I shift it downwards, this will form a 90 minus alpha, so this will become alpha. So this is m1g cos alpha, and this one become m1g sin alpha. Now T dash minus m1g sin alpha, T dash minus m1g sin alpha is equal to m1 times a. This is the same acceleration as this pulley because they are connected to each other, right? So whatever acceleration this small pulley has, this pulley has, the same acceleration the mass m1 will have. Now what about this tension T dash? Now let's look at the free body diagram of this pulley here. This pulley will have free body diagram like this. There is a tension force T dash here and the two tensions 2T here. Now if we have assumed the massless pulleys, okay, I have not said at the beginning of this question, but actually these are massless pulley, we have to assume that. So then you can say T dash is equal to 2T. So T dash is equal to 2T, so I can write instead 2T minus m1g sin alpha is equal to m1a. This is my third equation. Now we have to eliminate T, so to find out the acceleration, right? So let's do that. Now what if I multiply the first equation by 2? If I multiply first equation by 2, it will become 2m2g minus 2t is equal to 4m2a. This is my fourth equation. Now let's add this third and fourth equation. Then we will get, then what we will get, 2m2g minus m1g sine alpha is equal to m1 plus 4m2 times a. So a will become 2m2g minus m1g sine alpha divided by m1 plus 4m2. This is the acceleration.